Welcome. In this tutorial, you'll learn how to use the USM Go, a standard ultrasound system made for accurate and trustworthy internal defect detection in various materials. Its easy-to-use interface, combined with its light and small design, makes it a perfect tool for on-site inspections, especially in welding, metal frameworks, tubing, and other important industrial parts. This video will give you a technical guide on how to set up, standardize, and optimize its operation for accurate and safe inspections. Join us. General specifications: 5-inch display with a resolution of 800 by 480 pixels. Weight: 850 grams, including battery. IP67 rating: dust-tight and protected against immersion in water up to 1 meter deep for 30 minutes. Operating temperature: 0 to 55 degrees Celsius. Measurement units: millimeters, inches, or microseconds. Measurement resolution: hundredths of a millimeter or thousandths of an inch. Lithium-ion battery with up to 6 hours of operating time. Connectors: 2 LiMo00 connectors for transducers. SD memory card with a capacity of up to 32 gigabytes. Storage: allows saving test reports, screenshots in JPG format, and video recordings of the A-scan. Included evaluation modes: AWS-D 1.1, DGS, DAC curves, and TCG. At the top of the unit, we find 3 interfaces. The first is a service interface, used for alarm output and for maintenance purposes by the manufacturer. The second is the SD card slot, where we can store inspection files and screenshots. And finally, a mini USB port for transferring files to a computer. On the right-hand side, we have the power button, 2 LiMo00 connectors, and the charging port, which features a red mark that serves as a guide to connect the charger correctly. At the back of the unit, you'll find the battery compartment. To access it, turn the screws a quarter turn to remove the cover. Once the battery is removed, you will see 5 LEDs indicating the charge level: 20, 40, 60, 80, and 100%. It is important to align the battery connectors with the unit's pins before installation. We then place the battery back into position, replace the cover, and turn the screws back to their locked position. Finally, on the rear cover, there is a reference block called the 0 block, used for zero adjustment of the transducer. Now, let's talk about the elements on the screen. At the top of the display, you'll find the battery level icon. This icon indicates the remaining operating time in hours. When the charger is connected, the icon changes to show the charging percentage. Next, we have the measurement bar. This bar can be configured to display up to 7 measurements simultaneously. In the upper left corner, the current gain value is displayed, along with the decibel step, which allows you to increase or decrease the gain in increments of 0.2 decibels. Below that, you'll see the icon indicating the operating mode of the transmit-receive connectors and the icon showing that an SD card is inserted. At the bottom of the display are the first-level function groups for configuration. The selected group is highlighted in green. On the left-hand side, the functions corresponding to each group are shown. And finally, in the center, we have the A-scan. The horizontal scale represents distance or time, and the vertical scale represents amplitude in percentage. There are 2 independent gates that perform measurements of the corresponding echo. Keyboard functions. The top keys are used to gradually increase or decrease the gain level, in other words, the decibels. The right and left keys are used to navigate between function groups or to adjust the values of the selected function. The up and down keys allow you to move within a function group or adjust values. To switch between the first and second operating levels, press and hold the center button for 2 seconds. To return to the first operating level, press and hold the center button again for 2 seconds. This same button can also be used to expand the A-scan by pressing it once. The function 1 and function 2 keys are used to activate user-assigned functions or to adjust values. Some actions can also be performed using key combinations. If we press the top keys simultaneously, once, the gain will automatically adjust to bring the amplitude to 80% of the echo intercepted by the gate. To perform a system reset, press and hold the gain increase key and the function 2 key. Then power on the unit. At the bottom of the display, a message will appear, indicating that the unit has been successfully restored. Now we will talk about the function groups available on the equipment. The first configuration level shows 7 function groups. The first group contains functions for setting the signal display. The range represents the viewing distance in the A-scan. You can make fine adjustments with the left and right keys, or wider adjustments with the lower keys. The probe delay is the time it takes for the pulse to travel from the piezoelectric crystal to the contact surface with the material. This value is expressed in microseconds and is adjusted during calibration. The next function sets the sound velocity in the inspected material. You can select different materials and their velocities using the lower keys. Depending on the wave type, longitudinal or shear, and the material, you will select the reference velocity. This value will change during calibration. The display delay allows shifting the A-scan display to a specific section of the material. The second group contains pulsar settings. The pulsar voltage is the electrical energy sent to the piezoelectric crystal. It can be set to high or low depending on whether greater penetration is needed in thick or attenuating materials, to improve signal-to-noise ratio, or to increase sensitivity. The next function sets the sound energy to low or high, which affects penetration and resolution. Damping controls the number of crystal oscillations after emitting a pulse. It directly affects resolution and sensitivity and can be set between 50 and 1000 ohms. Pulse repetition frequency, or PRF, is the number of pulses emitted per second. For large components, PRF should be lower to allow echoes to return before sending the next pulse. The third group contains receiver settings. The first function allows selecting the probe frequency. If the frequency is unknown, you can choose a bandwidth instead. Wave rectification can be set to full wave, radio frequency, negative half wave, or positive half wave. Dual mode should be off when using single probes and on when using dual or double element probes. Through transmission mode is enabled when using 2 separate probes. Reject removes a percentage of echo height from the A-scan display. The fourth group contains evaluation functions. In this group, names and available functions vary depending on the evaluation mode selected. The fifth group is for semi-automatic calibration. Gate A start allows moving the gate along the A-scan. Reference 1 and Reference 2 are where you enter the smaller and larger reference values from the calibration block. The record function stores the reference echoes required for calibration. The 6th and 7th groups are used for Gate A and Gate B settings. Each group allows setting the start, width, and height of the gate. In flank mode, the maximum amplitude within the gate is measured, along with the distance or time of flight from the first intersection between the echo and the gate. In peak mode, amplitude and distance are measured at the point of maximum amplitude inside the gate. Finally, note that these functions also apply to gate B. In the second operating level, we find 7 additional function groups. To access this level, press and hold the center button for 2 seconds. The first group contains functions for managing calibrations, test reports, and stored videos. We can create a header or a note, and by selecting the Yes option, this information will be displayed in the report. Under the Action function, we can create a report, generate a quick report, load or delete a set of parameters or a calibration, view a report, and store a dataset. If we want to save a calibration, parameters, or a report, we assign a file name and move to the Enter option, confirming with the center button. We can also choose the storage folder. When saving a report, we can add an image of the A-scan and the list of parameters. To include them, simply activate the Yes option for each function. It is also possible to view and save the complete list of current parameters. In the next option, we can record a video of the A-scan during inspection. To do this, we select the storage location, assign a file name, and move to Enter, confirming with the center button. To start recording, press the right navigation key. At the top of the display, the recording time and speed will be shown. To stop, press the right key again on the Stop function. At the bottom, a message will confirm that the file has been successfully saved. To play a video, select Play, choose the file name, and move to Enter. Repeat the same process to start or stop playback. In the second group, we find functions to select the evaluation mode and configure the measurement readings. To access this menu, move to the second group. We can select between Reference dB mode, DAC and TCG curve, or AWSD 1.1. We can enable or disable leg color, expand the gate, or activate automatic gate height. When using an angle beam probe, we select the refraction angle. The K value represents the tangent of the selected angle. In the thickness option, we define the thickness of the part to be inspected. It is also possible to enter the X value, which indicates the distance from the probe index point to the front edge of the probe or wedge. If the inspection surface is flat and parallel, we select the Flat option. For curved surfaces, we can enter the outer diameter of the part, and the instrument will automatically correct the beam path distance and depth. At the top, we have the readings available in the A-scan bar. Echo height or amplitude in gate A, sound path or distance, difference between A and B gate paths, depth, projection or surface distance, reduced projection, which applies if the X value was entered, and the leg number. The same readings can be configured for gate B. Finally, for this subgroup, we can display up to 6 readings on the display. If we want to activate a visual alarm, we can assign the virtual LED function to the 7th reading. The extended mode allows us to increase or decrease the number of visible readings. The third group varies depending on the selected evaluation mode and includes specific functions for its configuration and adjustment. The fourth group contains general equipment settings, serial number, enabling advanced functions using a code, confirming the entered code, showing maximum amplitudes, changing the language, measurement units, choosing point or comma as the decimal separator, adjusting the date format, setting the date, time, display orientation, joystick lock, and color scheme. There are 4 available color schemes, 2 for indoor use and 2 for outdoor use. You can also configure the type of grid, the A-scan color, and finally, the display brightness. The 5th group contains special configuration functions. Function keys 1 and 2 can be customized to activate quick functions. For example, if we assign Freeze Display to function key 1, when we return to the A-scan and press that key, the function will activate and the Freeze Display icon will appear in the top left corner. To unfreeze the display, simply press F1 again. Available quick functions include Freeze Display, Lock Joystick, Save Report or Screenshot, Auto Amplitude at 80%, Expand Gate, Decibel Step, Load a data set, Load calibration or parameters, Change display orientation, Enable envelope, Access the main menu, increase or decrease the refracted angle, and record video. All these functions can be assigned to function key 2. The next function displays information about the instrument. Fill echoes on the A-scan. Enable or disable gates A and B. Automatic tracking of gate B in relation to gate A. Visual alarm output for both gates. Calibration reminder at a defined interval. Reset calibration reminder. Set gain step as predefined or custom. Select pulse type, either spike or square. And finally, adjust the pulse repetition frequency. The 6th group contains additional configuration functions. The freeze display mode allows you to stop the A-scan manually or automatically when the echo crosses gate A, gate B, or either of the 2 gates. The comparison mode shows a frozen A-scan in the background and the active scan in the foreground. To use any freeze mode, you need to assign the freeze function to function key 1 or function key 2, as explained in the previous group. The envelope function lets you display a frozen A-scan in the background along with an active scan in the foreground. You can also select the envelope color, enable automatic shutdown after a defined period, and set reminder functions for the annual calibration. The 7th group contains functions for automatic gain control. The instrument can operate in expert mode or inspector mode. In expert mode, specific functions can be disabled, which will not be available in inspector mode. This protects the equipment configuration. To activate this function, a password must be set. Once saved, it will only be possible to return to expert mode by entering the password. The automatic gain control adjusts the echo amplitude to keep it within a specified range, compensating for amplitude variations. A maximum amplitude and a minimum amplitude are defined for the echo inside the gate. It is also possible to set a noise threshold. The last function allows formatting the instrument's SD card. Now we will perform the preliminary adjustments for the straight beam calibration. As the first step, We enter the second level functions and go to the units option to change them to inches. We return to the A-scan display and set the range to 5 inches. The probe delay at 0 microseconds. The velocity corresponding to longitudinal waves in steel. The display delay at 0 microseconds. Voltage and energy set to high. Damping at 50 ohms. The pulse repetition frequency set to auto high. We select the frequency of the probe to be used. If the frequency is unknown, we can use broadband. For this example, we will use a 5 MHz probe. For wave rectification, we select full. Dual mode, off. Reject at 0%, and then we move to the Gate A submenu, where we set the gate height at 20%. And the measurement mode to peak. We enter again into the second level functions group. In the evaluation submenu, the angle value is set to off. The thickness is set to 1 inch. For calibration, we will use 2 reading measurements. In reading 1, we select SA, and in reading 2, A, % of A. And we deactivate the other readings. Large readings mode, on, and Gate B, deactivated. It is important to mention that the values of these and other functions will depend on the test conditions, the type of material, and the thickness of the component to be inspected, among other variables. Therefore, the configuration and adjustments of the instrument may vary. It is time to perform the straight beam calibration using 2 known references, with a step block and a 5 MHz transducer. We begin by entering the Auto Calibration function menu. For reference 1, using the lower keys, we enter the value of the smaller thickness. In this example, 1/2 inch. For reference 2, we enter the value of the larger thickness, 1 inch. For fine adjustment of these values, use the left or right navigation keys. Place the transducer on the step corresponding to 1/2 inch. Increase or decrease the gain until the first echo reaches approximately 80% amplitude. This is for reference only. Move the gate to the first echo. In the record function, press the right navigation key once to enable the auto calibration function. To save the first reference, press the right key again. Next, place the transducer on the 1 inch step. If necessary, adjust the gate so it aligns with the corresponding echo. To save the second reference, press the right key again in the record function. A message will appear at the bottom of the screen indicating that the calibration was successfully completed. Verify the reference values, 1/2 inch and 1 inch. Once the distance calibration is completed, the first function group will display the transducer delay value and the calculated velocity. It is important to note that when saving references during calibration, the gate must be positioned on the corresponding echo. Otherwise, the instrument will display an error message. When only one reference is available and the component to be inspected is thicker than that reference, we can perform calibration using multiple echoes. We will use the same initial settings as in the previous calibration, but this time, using only the 1 inch thickness of the block as our reference. In the Auto Calibration menu, enter the known thickness value as reference 1. For this example, 1 inch. For reference 2, enter the value of the second ultrasonic path, 2 inches. Now place the probe on the 1-inch thickness of the block. Adjust the gain until the first echo reaches approximately 80% of full screen height. This is only for reference. In the record function, press the right navigation key once to activate auto-calibration. To save the first reference, press the right key again. For the second reference, move the gate to the second echo. And press the right key in the record function. A confirmation message will appear, indicating that calibration has been completed successfully. Verify the reference values, 1 inch and 2 inches. Any repeat echo may be used. The correct choice will depend on the maximum thickness of the component under inspection. This completes the straight beam calibration. Now we will perform the preliminary adjustments for standardization using a dual crystal probe. Set the range to 5 inches. Set the probe delay to 0 microseconds. Select the velocity for longitudinal waves in steel. Display delay 0. Set the voltage and energy to high. Damping 50 ohms. Pulse repetition frequency auto high. Select the probe frequency to be used. For this example, we select 5 MHz. Wave rectification full wave. Dual mode on. Rejection 0%. Gate height 20%. Gate measurement mode, peak. In the second level functions, set thickness to 1 inch. Angle value off. In reading 1, select SA. In reading 2, select A over A%. Deactivate the other functions and disable the rest of the readings. Finally, deactivate Gate B. Now we will perform the standardization using a dual probe and 2 known references. To begin, we access the auto-calibration menu. In reference 1, we enter the value of the smaller thickness to be used. In this example, 1/2 inch. In reference 2, we enter the value that corresponds to the larger thickness, 1 inch. We place the probe on the block at the 1/2 inch thickness. We adjust the gain until the first echo reaches an amplitude of 80%. In the record function, we press the right navigation key once to activate auto-calibration. To save the first reference, we press the right key again. Next, we place the probe on the 1 inch thickness and move the gate. To save the second reference, we press the right key in the record function. We then verify the reference values. 1 inch, and half an inch. Standardization can be performed with different references, either from a quarter to 3/4 of an inch, or from half an inch to 1 inch. This will depend on the minimum and maximum thicknesses to be inspected in order to select the references. Angular beam standardization. For the standardization with an angular beam, we will use the IIW Type 2 block and a 2.25 MHz transducer with a 70-degree wedge. We make the following adjustments. Range, 10 inches. Probe delay, 0. Select the velocity corresponding to shear waves in steel. Display delay, 0 microseconds. Set voltage and energy to high. Damping, 1000 ohms. Pulse repetition frequency, auto high. Select the transducer frequency to use. For this example, we select 2.25 MHz. Wave rectification, full. Dual mode, off. Rejection, 0%. Gate height, 20%. Gate measurement mode, peak. In the second level functions, we configure refraction angle, 70 degrees. In automatic mode, the K value is adjusted, which is the tangent of the selected angle. Thickness, 4 inches. We will use 4 measurement readings. Reading 1. Select SA, distance or path traveled. Reading 2. Select A, % of A, representing the echo amplitude that crosses gate A. Reading 3. Select PA, projection or surface distance. Reading 4. Select DA, gate depth, and deactivate the rest of the readings. Finally, deactivate gate B. The values of these and other functions will change according to the requirements of the test to be performed. After the previous adjustments, we are ready to perform angular beam standardization. We begin by verifying the beam exit index point. Place the transducer on the block, aligning the line marked on the side of the wedge with the center of the 4-inch radius, directed toward the curved surface. Move the gate over the indication and adjust the gain so that the signal reaches approximately 50% of the vertical scale on the screen. Next, move the transducer back and forth until you obtain the maximum amplitude of the indication. Once obtained, without moving the transducer, check if the mark on the wedge coincides with the mark of the 4-inch radius curvature engraved on the block. If it does not coincide, place a piece of tape on the side of the wedge and mark on the tape the point that aligns with the center of the block's curvature. That will be the new index point of the wedge. Distance standardization. To begin the distance standardization, go to the AutoCal menu. Enter the values of the 2 known references. For reference 1, enter the value of 4 inches. For reference 2, enter the value of the second ultrasonic path, 8 inches. Place the transducer on the block, directed toward the curved surface, aligning the wedge index point with the slot at the center of the 4-inch radius. Position the gate on the echo from the radius and adjust the gain until the indication reaches an amplitude of 80%. In the record function, press the right navigation key once to activate the auto-calibration function. Save the first reference by pressing the right key again. Next, move the gate to the second echo. Increase the decibels slightly so that the indication amplitude touches the gate. To save the second reference, press the right key once more. Finally, verify that the distances are correct. 8 inches and 4 inches. Refraction angle verification. To verify the refraction angle, use the graduated scales on the side of the IIW block. Go to the Auto Calibration menu, then select Auto Angle. Based on the block and angle to be used, select the corresponding block and graduation on the instrument. In this example, since we are using a 70-degree angle, we select the IW block for the 60 to 75-degree range. In the block function, the instrument displays two values: 2 inches, which is the borehole diameter, and 1.2 inches, which is the depth from surface to the borehole center. Once the block is selected, place the transducer so that the wedge index point aligns with the graduated line corresponding to the 70-degree angle, and aim it at the 2-inch diameter borehole. Position the gate on the echo and move the transducer back and forth until the indication reaches its maximum amplitude. Once obtained, and without moving the transducer, press the right key once on the Save function to activate the angle auto-calibration. To save the refraction angle, press the right key again. At the bottom of the screen, a message will appear indicating that the angle auto-calibration has been successfully completed, and it will display the new calculated angle value. The allowed tolerance, according to document AWSD 1.1, is plus or minus 2 degrees. Sensitivity adjustment. For the sensitivity adjustment, we will follow the procedure according to AWSD 1.1. To begin, go to the second operating level and select the evaluation mode, AWSD 1.1. Return to the A-scan and open the AWS menu. Place the transducer aimed at the 0.060-inch diameter hole. Once the echo from the hole is identified, position the gate on the echo and move the transducer back and forth until the maximum amplitude is obtained. Once obtained, and without moving the transducer, adjust the gain so that the echo reaches an amplitude between 40% and 60% of the vertical scale. For this example, we will use 50%. In the AWS menu, under Reference B, press the right navigation key once to save the decibel value as reference level B. On the left side of the screen, the evaluation mode will be displayed for the classification of discontinuities according to AWSD 1.1. DAC curve. Another evaluation mode is through the DAC curve, which is an electronic compensation based on a known reference of the same size at different depths. This allows us to establish the relative size of a discontinuity. Now we will create the DAC curve. According to the thickness to be inspected, we select the block thickness. For this example, we will use a basic ASME block with a thickness of 1.5 inches. Previously, we performed the distance standardization using a 5 MHz transducer, 1/2 inch in diameter with a 70-degree angle. Enter the Evaluation submenu. In the Evaluation Mode function, select DAC curve and set the block thickness to 1.5 inches. Return to the A-scan and go to the DAC function group. Place the transducer aimed at the 1/8 inch diameter hole located at 1/4 of the block thickness. Position the gate on the echo and move the transducer back and forth until the maximum amplitude is obtained from the echo corresponding to the hole at 1/4 T. Once the maximum amplitude is found, adjust the gain so that the echo reaches 80% amplitude. In the record function, press the right navigation key to save the first point. This will be our reference level. Now, place the transducer directed toward the hole located at 1/2 T. Position the gate over the echo and move the transducer back and forth until finding the maximum echo amplitude. Without changing the gain, go to the record function and press the right key to save the second point. To obtain the third point, place the transducer toward the hole located at 3/4 T. Search for the maximum amplitude by moving the transducer back and forth. Without changing the gain, press the right key again to save the third point. We can continue creating more points by locating the holes at 3/4 T, 1/2 T, and 1/4 T, but now in the second leg, using an extended ASME basic block. The number of points in the curve will depend on the weld thickness and the ultrasound travel distance, ensuring the weld bead is fully covered. Finally, press the right key on the Finish function to complete the curve. We can change the shape in the Type function, switching from curve to straight. If we want to delete the curve, go to the Delete function and press both lower keys simultaneously once. It is also possible to edit each point of the curve. In addition, we can create additional curves to establish different sensitivity levels. To do this, select Customize in the Mode function and create 2 additional curves. We customize the sensitivity level of the first additional curve to 50%, that is, -6 decibels, which represents a discontinuity half the size of the reference level. Next, we plot another curve at a sensitivity level of 20% of the reference level, equivalent to minus 14 decibels. With the option to create up to 4 additional curves. This concludes the creation of the DAC curve. We can activate leg color display to visually represent the first 3 ultrasonic beam paths. To do this, go to the Evaluation menu and enable the leg color function. If we want to store a curve, a calibration, or the equipment settings, we go to the Files menu. In the Action function, select Store Dataset. Then assign a name to the file. Use the up and down keys to select each letter and the left and right keys to move to the next position. Once the name is entered, press the center button on Enter to save the file. At the top of the screen, a message will confirm that the file has been successfully stored. To load a previously stored file, proceed as follows. As a demonstration, we will reset the instrument. A reset is not required to load a file. This is just for illustration purposes. To load the saved file, go back to the Files menu. In the Action function, select Recall Dataset. Then search for the file name you want to load. Press the center button on Enter. All the stored settings will be restored. Finally, press Function key 2 to unfreeze the screen. This concludes the explanation on the proper use and handling of the USM Go flaw detector. We hope this tutorial will be a valuable tool in your inspections. See you next time.